Hi, today we're going to learn how to graph a polynomial. So in this section, I will go over all the steps of graphing a polynomial. I will go over end behavior, x-intercept, multiplicity, rational zero theorem. So there's like 3 steps to graph a polynomial. So the first step is to determine and graph end behavior. The second step is to find x-intercept and multiplicity by using rational zero theorem and synthetic division, and then factoring by grouping or simple factoring. And then the third step is to find y-intercept by plugging 0 into x and solving for y. So this may sound a little confusing, but I will go over it step by step. So the first problem says we got to graph this polynomial. So it's f of x equals negative x cubed minus x squared plus 5x minus 3. So the first step is to determine and graph the end behavior. So how do you find the end behavior? So you look at the highest degree, which in our case is the third, and then you look at the so the first step is determine end behavior. So you look at our highest degree is the negative x cubed, right? So I'm going to write negative x cubed. And then you have to look at 2 things, the degree and then the coefficient. So there's an invisible negative one right here, right? So we know it's odd degree. It's odd degree and negative, and it has a negative coefficient. So that means there's going to be a reflection on x-axis. So the end behavior is it's going to increase to the left, increase to the left, or quadrant 2, and decreases to the right. Or quadrant 4. So it's going to look something like this. So we remember it's this is a 3. So remember there's reflection on the x-axis. If it was positive, it would have went something like this, right? But there's a negative, so it's going to increase to the left, or quadrant 2, and then decrease to the right in quadrant 4. So this is our end behavior. So make sure you keep that in mind. So now the next step is to find the x-intercept. So find x-intercept using rational zero theorem. Using rational zero theorem. So hold on. Let me clear the board because I need more space, so press pause if you need to. I'm just going to clear the board. So let me rewrite it. So the equation was f of x equals negative x cubed minus x squared so we're in step 2, so we're gonna find the zero. We gotta find the x-intercept using rational zero theorem. So rational zero theorem is, you basically set this as p, it's p over q, so this is our p, which is just 3, and our q is 1. So we say that our p is not the negative 3, but just the 3. And then our q is not the negative, it's always the coefficient, so it's just positive 1. So tell me, what are the factors of p, or the possibilities that makes up the 3? We can use plus or negative, right? Plus or negative 1 and 3, because 1 and 3 makes up the factors of 3. And then what are the factors of 1? We can use plus or minus, because negative is still a possibility, so plus or minus 1. So the rational zero theorem is p over q. Our possibilities, so p over q is all our possibilities, or our zeros, is plus or minus 1, 1 and 3, because when you do p over q, you still get, so 1 over 1 is 1, and then 3 over 1 is 3. So that's how I got plus or minus 1 and 3. So those are our possibilities. Now we got to use synthetic division to figure out which one is our zeros, or which one is possible, is it one of our x-intercept. So yeah, now I will use synthetic division. So I will use negative 3. Let's see if this works. So to do synthetic division, you put in negative 3 in the box, but when you factor out, it's not going to be negative 3, it's going to be positive 3, but I'll show you at the end. So to do synthetic division, you look at the original equation, and then you got to make sure everything is in order. So when I say order, the degrees are from highest to lowest, and then there's no missing degrees, right? So let's see, we have a 3rd degree, 2nd degree, 1 degree, and a 0 degree. So everything's ordered, so all you got to do is put in the coefficients. So this is going to be a negative 1, this is going to be a negative 1, this is going to be a 5, and this is going to be a negative 3. So here's negative 1, negative 1, positive 5, and then negative 3. Put that line under. And then on the first one, you can always put an invisible 0 if that helps. So 0 plus negative 1 is negative 1. Negative 1 times negative 3 is positive 3. 3 plus negative 1 is positive 2. 2 times negative 3 is negative 6. Negative 6 plus 5 is negative 1. Negative 1 times negative 3 is positive 3. So this is 0. So when you have a 0, that means negative 3 is possibility, is one of the factors. If you have a remainder, then it's not divisible. So you have to keep on going until you get a 0. So now your new equation is going to be see these -1, 2, and -1? These are your coefficients, so it's going to be -1, and then it's going to be x. Now you have to look at the original equation. This was originally, it's always 1 degree from the original equation. So instead of cube, this is going to be square. It's always 1 degree from the original one. So this is going to be square. This is going to be plus 2x, and then minus 1. And we can set that to 0. I'm looking at this and I can factor out a -1. -1, this is going to be x squared minus 2x plus 1 equals 0. And then you can factor out, divide everything by -1 to get rid of that -1. So I'll put it right here. So you have our new f of x. This is our factorial form. It's going to be x squared minus 2x plus 1. And then you have to remember this one, because this one's one of our factors. So it's not going to be x minus 3. It's going to be always the opposite. So it's going to be x plus 3. And you know it's the original one because when you FOIL this out, you should get this, right? And then you should have 3 x-intercepts. Okay, so but this one, x cubed minus 2x plus 1, it could be factored even more, right? So this is going to be x, and then this is going to be -1, -1, and then don't forget this x plus 3. But I can rewrite it as this x minus 1, I could rewrite that as x minus 1 square, and then x plus 3. Now, this is really important. This 2, and then there's an invisible 1. This determines my multiplicity. So hold on, let me, I'm going to have to erase the board again, so press pause if you need to. So this was our original equation, x cubed minus x squared. Yeah, just make sure you write everything down because I have to keep on clearing the board because the board is kind of small. So we said that in the factorable form is x minus 1 square and then x plus 3. How we got this is we used the rational zero theorem, and then we use synthetic division. That's how we got it. And then if you were to FOIL it, you would get this original. That's how we know it's correct. So now we got to talk about multiplicity. So over here, okay, so our x-intercept, if you set this to 0, right? And then x plus 3, our x-intercept is going to be one of them is going to be 1, 0, and then you look at the degree right here, right? So this has a second degree. It has an even multiplicity. Even multiplicity. So what that means is it bounces on x-intercept, and this will all make sense when I graph it. So when something bounces, right? Let's say this is a -1, and then, so wait, let's say it was right here. This is 1, 0, and when they say it bounces, it's going to go like this. Bounce on the x-intercept. And then our other x-intercept is -3, right? -3, 0. Where we got this one is from this. And then this has a multiplicity of 1. So that means it's an odd multiplicity. So this is an odd multiplicity. And what that means is it crosses the x-intercept. Crosses x-intercept. So that means, let's say it was right here. So this is -3. So what it means is if it crosses, it just goes something like this. It just literally crosses the x-intercept. So, but this is not how our graph is going to look like. And okay, so we know the end behavior, we know the x-intercepts, and then our last step is to find that y-intercept. We need all this to graph a polynomial, so we got to find. So make sure you write everything down because I'm gonna have to erase it again. Find y-intercept. So to do that, you just literally plug in 0 for x. So our original equation is y equals -x cubed minus x squared plus 5x minus 3, right? So what you do is you plug in 0 for x, so it's going to be y. Wherever there's an x, you plug in 0. So it's going to be 0 minus 0 plus 0 minus 3. So you're left with y equals 3. So our y-intercept is 0, 3. So remember, write this down, write all of this down because we need this to graph. So now our next step, our final step is to graph. So I'm going to erase it again. So our final step is to graph. This is your x-axis, y-axis. So we said that the y-intercept hold on. So remember we said from the original, here's our original equation, f of x equals -x cubed minus x squared plus 5x minus 3. Remember we said that the end behavior, our first step was to find the end behavior, and then our end behavior looks something like this. Right? It looks something like y equals -x cubed. So our end behavior, remember, it rises to the left and then decreases to the right. So it rises in quadrant 2 and decreases in quadrant 4. Okay, so we know our end behavior. We know our x-intercept. So our x-intercept is, remember, it's in this form. When we did the synthetic division, our factor form was x minus 1 square and then x plus 3. So our x-intercept was 1, 0, and it has an even multiplicity. And then our other x-intercept is -3, 0, and that was an odd multiplicity. So when even, it bounces. It literally, so bounce means it just bounces on the x-intercept, and when it's odd, it crosses the x-intercept. So it's gonna go, it just literally crosses. So first step is I'm gonna plot my x-intercept. So here's -3, 0. And then our other y-intercept is 1, 0. So this is going to be right here. So this is 1, 0, and then this is -3, 0. And then our y, gotta make sure our y-intercept is 0, 3. So 0, 3 should be right around here. -3, sorry, it's -3. So we know our x-intercept and our y-intercept, and we know our end behavior. So I think now we can graph it. So we said that, so it says that it rises to the right, to the left, right, in quadrant 2. So it's going to go something like this. That's our end. This is our end behavior. And then then it decreases on the right, or quadrant 4. So it's going to go something like this. So now, remember, now we got to look at our x-intercept and do the if it crosses or bounces. So here's -3. -3, we got it from here, and then we said it's odd, so that means it crosses. So it's gonna go crosses. So it's literally crossing the x-intercept, and then it passes through the y-intercept. So it goes like this, 0, 3, and then over here our other x-intercept is 1, 0, and it has an even multiplicity. So what it means is if it bounces, it's not going to go right through the x-intercept. It's just going to bounce, right, like a parabola. So it just bounces. So this is how your this is what your polynomial of f of x equals negative x cubed plus, negative x cubed minus x squared plus 5x minus 3. So this is how you graph a polynomial. And if you want if you want something like over here, you can plot in f of -1, right, to get this y value. If you want it to look really really detailed, you could plug in -1, and then you will get your y value. If you want it, if that's what if you want something to look really detailed. But so yeah, but this is just the basics. You got to find the end behavior. You got to find the x-intercept by using the rational zero theorem and synthetic division. Once you got your factor form right here, like, you got to then you got to find your x-intercept, and then you got to figure out if it's an even multiplicity or an odd multiplicity. And if it was an even, like over here, it bounces the x-intercept, and if it's odd, it crosses the x-intercept. And then you could find the y-intercept by plugging 0 into the x values. So I'll do another one, and then that'll be our last one for today, because these kind of take long. So this is our last one. So I'm going to keep on erasing the board because this takes a lot of space, so it's really important to just write everything down. So this one is f of x equals x cubed minus 40 x squared, right? So we got to find the end behavior. First step is find end behavior. So remember, you look to find the end behavior, you look at the highest degree, which is cubed. So our highest degree is our x cubed, and we look at two things, the degree and then the coefficient. So there's an invisible one. So we know this is not a negative, it's a positive, so there's going to be no reflection. So yeah, you have to look at the coefficient if it's positive or negative. In our case, it's positive. So there's no reflection. So we know that it's an odd degree. So in odd degrees, it's going to look something like this. So we know that it rises to the right. That is quadrant 1 or quadrant 1, and decreases to left. This is quadrant, that would be in quadrant, this is quadrant 3. So we know our end behavior. Now let's find our x-intercept. We got to find x-intercept using rational zero theorem. So remember, this is going to be the 40 is going to be our p, and the 1 is going to be we're looking at the coefficient. So p is always the last number, the last term, which is negative 40 x squared. So we look at the coefficient, so negative 40, and then the q is our first term. It's always the coefficient. So we said that the p is 40, and our q is just 1. It's the coefficient. So what are the possibilities of 40? So the possibilities of 40 is going to be plus or minus 1, 2, 4, 5, 8, 10, 20, and 40. And then the possibility of 1 is just plus or minus 1, right? Now, when you do the p over q, because that's a rational zero theorem, p over q, our possibilities are now just 1, 2, 4, 5, 8, 10, 20, and 40. These are our possibilities. So you gotta just literally pick and check, guess and check one. So I will use 40, just regular 40, positive 40. And then to do synthetic division, you have to look at the original equation, and then you have to make sure everything's in order. So we have an x cubed minus 40x squared, and then it doesn't keep on going. So it doesn't have an x and then a regular number. So when you don't have that, whenever you're missing something, you plug in 0 for that. So over here we have an x cubed, and then we just put the coefficient. So it's going to be 1. And then our next term is x squared, but we just care about the coefficient, so that's going to be negative 40. and then but we don't have an x and a regular number, right? So in that case, you have to put a 0. So this is going to be 0, and then the next term is going to be 0. And then you could put invisible 0 on the 1. Then 0 plus 1 is just 1. And then 1 times 40 is positive 40. 40 plus negative 40 is 0. 0 times 40 is 0. 0 plus 0 is 0. 0 times 40 is 0. So yes, this is a factor. This definitely is factorable. So remember we said we look at the we only have one term, so it's going to be 1, and then look at the original equation. This was originally an x cubed. Now it's going to be an x squared. So our factorable form is f of x. Our factor form is going to be x squared. And then don't forget this 40, right? So it's not going to be positive 40. It's always the opposite in factor form. So it's going to be x minus 40. Because when you solve for this, if you set x minus 40 equals 0, you get 40. That's how you know it's right. Okay, so that's our factor form. I'm going to have to erase the board again. So our factorable form is x squared parentheses x minus 40, right? We use the rational zero theorem, and then we use synthetic division to get these terms. So now let's look at the x-intercept. So our x-intercept, we should get 2. So if we set x minus 40 equals 0, and then x squared equals 0, our x-intercept is going to be 40, 0, and then how we got that? So this has a 1, so it's odd multiplicity, so it crosses on the x-axis, crosses on x-axis, and then our other x-intercept is 0, 0, right? Here's x squared. If you set that to 0 and then you solve for x, you get 0. But this one has an even multiplicity because it has a square, so it has an even multiplicity. So we know that it's going to bounce. Bounce on x-axis. Now we don't have. Now the third step is to find the y-intercept, but we don't have a y-intercept because if you set 0 onto x, it's going to be 0. It just passes through the origin, right? It passes through origin. So we don't really have a y-intercept. So the next step is just to graph it, and then, so I'm going to have to erase again. So yeah, so we're going to graph it. Okay, so what do we know again? So our end behavior looks something like this, right? This is our end behavior. So that is what our end behavior looks something like. Okay, so what else do we know? We know our factor form is f of x equals x squared times x minus 4. And we got that by using the rational zero theorem and synthetic division. So we know that our x-intercept is 40, 0, and we know it's odd multiplicity, and then so it crosses x-axis. And then our other x-intercept is 0, 0, and we know it's an even multiplicity. So we know it bounces x-axis, and we don't have, it passes through the origin, so we don't, so no y-intercept. Okay, so this one is not going to be hard to graph. So our first one is 0, 0. So this is 0, 0. That's one of our x-intercept, or it passes through origin. And then the other one is, this should be 40, not 4, sorry. So we'll call this 40. So at 0, 0, it's even multiplicity. Okay, wait, first let's do the end behavior. So it rises to the right, so it's going to be, so here's 40. This is our last term, so it's going to look like this. And then our last other term is 0, 0, so and it decreases on the left, so it's going to look something like this. So that is our end behavior. Now let's look at our x-intercept. So 0, 0. It has an even multiplicity, so it bounces. So it's going to bounce like a parabola. And then let's look at 40. We said it's an odd multiplicity, so it crosses x-intercept, so it's just going to go straight through. Whoops. So this is what it typically looks like of this polynomial graph. And if you wanted more details, you could let's say you wanted this point, right? You could just plug in f of 20, and then that'll give us your y value, right? And then because if you wanted most detailed, you wanted to know this point, you plug in, so this would be 20 comma something, right? If you plug in 20 into x, yeah, so let's say you plug in 20, you get 20 cubed minus 40 times it by 20 squared. You get negative 8,000. So this point is going to be 20 minus negative 8,000. So yeah, those are the steps of graphing polynomials. So you got to find the end behavior by looking at the highest degree, and then you look at the coefficient if it's positive or negative, because that'll determine any reflection. The second step is to find the x-intercept by using the rational zero theorem, or P over Q, and then use synthetic division to figure out if it's possible, if it's actually 0. And then then you write that in factor form, and then you determine if it's an odd multiplicity or an even. So odd is when it has an odd degree, and then even if it has an even. And in odd, it crosses the x-axis, and in even, it bounces. So this is even, so it crosses. This is odd, so it crosses. So when something crosses the x-axis, it just goes right through. And if it's an even, it bounces like a parabola. So it's going to like bounce like a parabola. And then the third step is to find the y-intercept. So you basically plug in 0 for x, and then you should get your y-intercept. So that's it for this section. If you liked my video, please subscribe or like my videos. If you have any questions, go ahead and leave comments. I would be happy to answer any of your questions.